Hey, hope you're doing good. This is Aditya, and today on the section 2 of assignment 2, we have been asked to analyze the predictive models used on the data supplied to the data scientists. And the data is basically from a cancer research and treatment facility, which was conducting a study, a research onto patients who might or might not have carcinogenic elements in their body. And how were they doing that? They were subjecting these cases, these patients, to low dosage of X-ray radiation. And the film which was generated after they have were subjected to this X-ray radiation was studied by expert eyes of doctors. And then they were classified into people and subjects who had magnet mass in the body or not, cancer or not. Now, the data which was supplied to the data scientists was 11,183 rows strong, and out of the mean data set, 260 cases actually had malignant mass in their system. So going forward in our section 2 of assignment 2, the first question is about validation statistics. As you can see on the screen, this is basically a confusion matrix. And the default version of a confusion matrix looks like these. As you can see, target is basically the actual data, and the predicted, as it is, are the predicted uh, values from the algorithm, from the model. As you can see, there are two classes, class 0. Class 0 is basically the class wherein there is no evidence of carcinogenic elements in the subject, and class 1 is the class wherein there is certain amount of evidence of carcinogenic element present in the subject, in the patient. So the data scientist chose three um, models. First is the decision tree. In the training set in which they're training the algorithm, we use 50% of the total data set, which is 11,183 rows strong. As you can see on the screen, for case 0, out of 5,462 cases which didn't have the carcinogenic element in the system, the algorithm predicted it pretty accurately with complete accuracy, and there was no case wherein it was predicted in an incorrect manner. Whereas for class 1, there were 129 cases which actually had the malignant mass in their system. But out of the total cases, 124 cases were identified as having the malignant mass in the body, as in the algorithm predicted it accurately, correctly, and there were 5 mistakes by this algorithm in the training data set, from the training data set. And now let's get on to the stats which were calculated from the confusion matrix. The first stat is overall accuracy. Overall accuracy is given as 0.991, which would be the accurate digits which are predicted by the algorithm. Over here, it was 5462, accurately predicted by the algorithm, plus 124, which was predicted as well accurately by this algorithm, the decision tree algorithm, divided by the total number of cases in this case, which was 50% of the total number of records, 11,183, which gives us 0.991. Now, let's come on to the accuracy of class 0. In class 0, as it predicted accurately, 10% accuracy as they call it, there was no case which it identified incorrectly. So we'll give it a 1 score when it comes to accuracy of class 0. For class 1 now, it will be 124, the number of cases which is identified accurately, divided by the total number of cases which had the magnetic mass, which gives an accuracy class rating for class 1 at 0.961. Now, the average class accuracy is the mean of these two values, accuracy of class 0 and accuracy class 1, the mean of these two divided by 2 in this case. Going forward, the main testing data, which is 30% of the total number of cases over here, We did the same calculation. We came out with the same result as in the previous example. But there is another thing over here which I have calculated, which is called as a misclassification rate. Misclassification rate is a very significant parameter when it comes to the accuracy for determining the accuracy of a prediction model. And over here, the misclassification rate, the rate at which the algorithm did some kind of misclassification for the decision tree algorithm, it is 0.017. And how is it 0.017? There is a formula for it, as it is misclassification rate is given by the division numerator given by FP plus FN. FP, false positive plus false negative, divided by the denominator, the summation of true positive, true negative, false positive, and false negative. This formula gives us the misclassification rate, and the misclassification rate for the first algorithm is 0.017. Going forward to the next model based on logistical regression, we have the similar calculation over here, and all these figures are calculated in the similar manner as the previous example. Going down to its testing data, which is 30% of 11,183, we get a misclassification rate over here of 0.0113. Everything else, all the parameters over here are calculated in a similar manner as was in the case of the decision tree algorithm. And the final algorithm over here is a random forest model. For the training data set, 50% of 11,183 would be 5591. In this case, class 0, the class wherein there is no evidence of carcinogenic element, malignant marks present in the body. And in this case, out of 5462 cases where there was no malignant marks present in the body of the subject, the algorithm predicted 5118 to be accurate, wherein it represented that the case had malignant mass in the system. As far as class 1 of the same algorithm is concerned, out of 129 cases wherein there was a malignant mass, it predicted 110 cases correctly that those cases had malignant mass, and it went wrong with 19 cases where it predicted incorrectly, giving a false prediction of not having malignant mass. The rest of the calculation is similar to the first example, as I said you. Coming down to the testing data of the random forest algorithm, the misclassification rate of the over here is so far the highest at 0.059, using the same formula as I have shown you before. Now, coming down to the question number 2. Basically, ROC. The data scientists who were carrying out the diagnostics on the data generated visualization for each of the models. These visualizations are the ROC, or the receiver operating characteristics. ROC curve is often used in medical research in order to compare the accuracy of the diagnostic test carried out. It is basically a graph between sensitivity and specificity. Sensitivity is termed as true positive rate, as you can see on the screen, and specificity is termed as FPR, or false positive rate. Now the ROC curve is drawn through cutoff points, and these cutoff points are generated by the values of the intersection of the true negative and the true positive. And if someone intends to change these cutoff points, they have to change the area of false negatives and false positives, basically. Different cutoff points have different specificities and sensitivities, and hence different areas under the curve. Now coming down to the ROCs which were provided for each of these models: decision tree, logistic regression, and random forest. As you can see on the screen, the ROC generated for decision tree does not represent a perfect test for diagnosing the result. And now, what is a perfect test? Perfect test is basically when the graph would have a curve which would represent something like this. The left portion of the curve would kind of hug towards the y-axis, which is basically the sensitivity axis, and the top portion of the curve would be somewhat parallel to the specificity axis or the x-axis. So going down to the ROCs which were provided to us, you can see that for decision tree algorithm, the ROC provided doesn't represent something which is a perfect curve. The left side of the curve does not go as close to the y-axis, and the top side of the curve is not as parallel as it should be for the ideal curve. And now the ROC for the decision tree is given to be 0.815 ROC. ROC, area under the ROC, pardon me, or also called as AUR, is basically the coefficient, important parameter determining the efficiency or how accurate the various ROCs are. This is a very important parameter. And the AUR for the case of decision tree is given as 0.815. The next model, the regression model, logistic regression model, the ROC is given as 0.939, which is the highest of the three, and it represents the ideal curve of the ROC. The left portion of the curve is kind of hugging the y-axis, and the top portion of the curve is somewhat parallel to the x-axis. As compared to the other models presented, ROCs for the model presented has the highest value as well. Now, for the last model, which is the random forest algorithm, the AUR, or the area under the ROC, is intermediary between the three. Highest is the logistical regression, the least would be the decision tree. And it somewhat represents the ideal curve for ROC as well. So this was about ROC, AUR, and all the three curves in comparison. Now coming to the last question. The question asks, recommendation of a model specifically to the team of medical professionals, what would be it? And my answer is I would recommend the logistical regression model to the team of medical professionals because of four important points. Basically, the area under the ROC or the AUR is highest in logistical regression model. As you can see, it was highest at 0.939. Secondly, the misclassification rate as well, as in the first question, was the lowest in the case of logistical regression, which is a very crucial parameter in the case of medical research because they need misclassification rate to be as low as possible in the cases of cancer research or any other disease. Misclassification for any of the ailments should be as low as possible. Thirdly, the logistic regression model is widely used in medical research, and the medical community is well acquainted with the calculations of ROC for testing diagnosis. And fourthly, ROC is good for binary classification. So thanks a lot